Okay, let's now take a look at review problems 4.9 and 4.10. The first question, how many 2x3 rectangles of either orientation can be found using the corners of an 8x8 chessboard? So for this problem, for example, something that like this would work. Okay, so this would be a 2x3 rectangle that works. Another possibility that could work would be something like this. So that rectangle is also 2x3, but in a different orientation. Okay, so let's count up the possibilities. The way that we'll do this is by counting, well, so first off, let's count the possibilities of the rectangle having this orientation. If the rectangle has this orientation, then if the upper left-hand corner falls over here, that we need that to happen, the upper left-hand corner could fall in this column. The upper left-hand corner could be over here, all the way to over here. So if the upper left-hand corner is in any one of these 6 lines, then if it goes out horizontally 3 steps, the whole thing will fall on the square. Likewise, coming the other way, the upper left-hand corner could be in any of these 7 rows. So if it landed here, then the rectangle will look like this, and that's all right. So as long as the upper left-hand corner is in one of these 6 rows and in one of these 6 columns or one of these 7 rows, then the whole rectangle would fit in the chessboard someplace. So there's how many ways of that happening? Well, there's 6 possible answers for your column, 7 possible answers for your row, so there's 6 times 7 ways of getting a rectangle to fit with this orientation. Now, by the same logic, this other orientation, there'd be 7 times 6 possibilities. And so that would be 42 plus 42, which makes 84 possible ways that you can put a 2x3 rectangle on an 8x8 chessboard. Now, the more interesting question is problem number 10. How many lattice paths using up and right motions are possible if we just go from the upper left-hand corner to the upper right-hand corner? So for example, we can go right, 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 up, 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 right, up, right, up, up, right, up, up, right. And that would be one way of going from the the lower left-hand corner to the upper right-hand corner by using only up and right motions. Okay, now let's think about this. So the path that I just did was right, 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 right. Then I went up 3 times, up, up, up. Then I went right, up, right. So right, up, right. That takes me here. Then up, right. So up, right. Then I have up, right again. Now, if I counted right, there should be 1, 2, 3, 4, 5, 6, 7, 8 rights, and 1, 2, 3, 4, 5, 6, 7, 8 ups, which makes sense. You have to go 8 times the right and then 8 times up to get from one corner to the other. So no matter what, there are 16 steps, and 8 of them have to be rights. So now this is a combination problem. How many ways are there of having 8 right? If you have 16 steps, 8 rights and 8 ups, how many ways are there of arranging these things, of positioning 8 right steps in a series of 16 steps? The answer is going to be 16, choose 8. There are 16 steps, of which we need to choose 8 of them to be right steps. And so the answer will be 12,870, plugging that to a calculator, or else using factorials. So the key observation is that there are 16 steps, there are 8 of them have to be rights, and so I have to choose the location of those where those happen to go. So 16 possibilities, of which we choose 8, and so the answer is 16, choose 8, 12,870.